screen up. Well, thank you all for joining me today. I'm excited to talk to you about expectations versus reality. This presentation will cover expectations versus reality encountered throughout the production lifecycle. And that lifecycle will be from prototyping to scaled production. The talk's intended for project managers to help you navigate expectations and forecast reality into your project planning. Before we get started, a little bit about myself. I'm the co-founder of Hummingbird Additive, where I focus on metal AM strategies and applications. One of the things that I like best about my role is getting to develop new capabilities with clients. And in order to do that, it's helpful to understand common expectations. So with that, let's dive in. The first expectation we'll discuss today is quantity. Quantity increases with production maturity. That makes sense. The second expectation is that labor will decrease over time. And this decreases as production scales. I want you to notice how smooth these lines are. These are the expectations that are common. But then there's reality. It's not actually that simple. So this is more of what a production life cycle really looks like. You'll see all of the different variation, and we'll go through what the different peaks mean throughout the presentation today. When you transition from one phase to the next, it'll require the most effort from your project team. And each phase has its own unique challenges to overcome. When you overlay cost, you'll see that cost is a lagging indicator of effort. So your production costs will increase until both your manufacturing and engineering inefficiencies are addressed. There are 4 key decision points throughout this production lifecycle that we'll talk about today. We have building prototypes, starting qualification, beginning production, and ramping up production. And we'll talk about the different questions you'll need to answer before you can proceed through each of the 4 gates. So let's start by looking at prototyping. Before you can pass through the gate to begin prototyping, you're going to need to answer a variety of questions from both your executives and your engineers. Keep in mind that executives want project definition, and they'll ask questions like, what is the cost benefit? Can we make a business case? And what level of investment is needed? Engineers are focused on product definition. So they'll ask questions like, how does AM compare to our current manufacturing method? What are the realistic feature tolerances? And what is the expected performance benefit? Once you've answered all of these questions, which both sets are important, we'll be able to proceed through the first gate and start building prototypes. So once we have the funding, we'll be able to develop our requirements. These will cover the form, fit, and function for our product. Once those are defined, we'll build, test, and iterate. And we'll continue to build, test, and iterate until we have our test results that show that our performance meets our requirements. When you're prototyping, be aware that rarely are legacy designs AM ready. You might even have inherited a legacy design that doesn't have a CAD model. So wherever that legacy design begins, you'll need to update it so that it is compatible with additive manufacturing. Keep in mind that your production unit price might be higher than your prototyping unit price due to the different quality requirements that you'll need to add. And during this phase, you'll be asked a variety of questions, many of which are forward-looking, about the product life and the production unit cost. But prototyping alone will let you accurately answer these questions. You'll need to wait until the next phase, qualification, before you can answer those. Prototyping is a time where you can spend time and effort just making sure you have the right material and technology fit for the capabilities that you need. Reminds me of a project that I joined. I joined after we ordered the first prototype. When we received that in, found out that it just didn't meet the performance requirements, which was a bit of a surprise. But we took a step back and decided to actually iterate the design and build it the second time using a different additive technology. When we received that prototype back and tested it, it not only met our performance requirements, but it also came in lower cost and with a shorter lead time. So prototyping is a time where you spend the time and effort to really make sure that you're coming up with a project that is worth taking to production. Now let's look at production. This phase has two gates. Gate 2 is starting qualification, and Gate 3 is beginning production. Before we can start production qualification, it's important to define our business case. What is the expected ROI? What are the time and resource investment needed? And what are the benefits to the bottom line? In addition to these items here, executives will ask forward-looking statements. When can we start production? And how do we market the product? It's important to keep your eye on the road ahead so that you can be prepared and have a market ready and waiting for once you're ready to start production. Before you can proceed to qualification, your engineers, who are again product focused, will ask questions like, what types of test data are needed and how many samples do I need? This is going to be highly dependent on both your application and your industry. They'll also ask, how can we mitigate risk? And are all of the production operations well defined? Once you've answered all of these questions, there'll be time for you to start qualification. So once you have the funding for qualification, you can create an initial procedure and your quality control documents. This is where you'll be spending the time to validate your technical capabilities by building qual units and test specimens. Once you have all of that data and you've analyzed it, you'll be able to go back and finalize your requirements and your procedures. You'll pay special attention to identifying key product features and metrics, as well as establish your inspection and pass-fail criteria that you'll use during production. During this phase, you'll also start to build trust with your stakeholders and your key customers regarding the product's quality and performance. And since we know that unit cost is a lagging indicator of effort, we're going to keep our eye on that unit cost because it will be rising as we add quality requirements. By taking the feedback from your stakeholders and key customers, as well as knowing that your unit cost will rise, you'll be able to go back and validate your final business case and technical case and send it out for approval. But before it can be approved, we'll have a few more questions to answer. Executives, again, want more project definition. So they'll remember that they asked you ROI targets back at the beginning before you started qualification. Now they'll want to know, did you hit those targets? Will this product hit all of our ROI targets? And then how have the risks been mitigated? And finally, when can the production rollout begin? They're again going to be focused to make sure that you have a market ready and waiting for this product as soon as it's ready to begin production. Engineers will want product definition. So does this product meet its performance requirements over lifetime? What is the unit cost and lead time? And what is our expected production yield? Once you've answered all of these questions, then you'll be ready to begin production. So now that we've entered production and you're in your first run, you'll see that the unit cost is increasing again because production's an evolving process. You'll probably find some additional requirements that need to be added. They only find out kind of when you're in the thick of it. Your unit cost will actually peak probably around your second or third run. This is after you've stopped adding additional requirements, so those are all locked down. And then you have found and identified the manufacturing inefficiencies. And perhaps you've taken into account previous underestimates and have everything more clearly identified now. You'll see that in your subsequent builds. This is where you can iron out those workflow inefficiencies that you identified. And as you do, the unit cost decreases accordingly. When in production, be aware that it's an ever-evolving process. You might have changes in personnel or a new vendor that you have to work with, and throughout this whole process, you'll be incorporating your lessons learned. One thing to keep in mind is that post-processing operations may be more of a cost driver than printing. Let's consider surface finishing as an example. Let's say your legacy product that you're carrying over was originally machined, and you just inherited the requirements that that part had. You might actually have machined tolerances and machined surface finish requirements that are in your initial baseline requirements. Well, when you as you all know, additive manufacturing can't actually achieve machined surface tolerance, machine surface finish and tolerancing. So you'll need to look into post-processing operations to meet those requirements. And some of those can be pretty expensive. So taking the time right in this, when you're defining your requirements, to understand what your actual requirements are for the product will allow you to find out if you need additional costly post-processing operations, or if you're able to eliminate some of those steps. Either way, come up with your realistic acceptance criteria. And being able to do that will balance the unit cost with your real product requirements. Throughout production, if you're making changes and incorporating lessons learned, keep in mind that any changes that you make to your processing steps might nullify previous risk reduction activities. So just keep that in mind. You might need to do some additional testing before you make some changes. At this point, if you're able to create a scalable manufacturing strategy that you can use and test out during production, that will provide you with many more options for future growth. So next, let's look at scale production. So before we can reach scaled production, we have studies to do. We'll need to decide exactly how we want to scale production, because there are several different options. We'll evaluate the benefits of using a larger AM system versus adding additional systems that are similar to the one we're already using. Once we've done those trade studies, we'll also be scrutinizing our workflow, and we'll see what areas we can standardize and streamline so that we can address our bottlenecks from printing all the way through post-processing. Here we'll refine our acceptance and inspection criteria based on historical data, keep in what helps and remove any unnecessary steps, and then we'll wrap all of that up and create an updated business and technical case for approval. Before we can scale, we again have a few more questions we're going to need to answer. Executives are going to want to know what the market projections are and the ROI for scaling production, what investment is needed, and then again that forward-looking statement, when will the additional capacity be online? They'll always be keeping an eye on the future to make sure that they have a large enough market ready and waiting for the capacity as soon as you have it online. Engineers will be product focused, and they'll ask, what's the impact of moving to a larger system? How can we improve our production yield? What effort is needed to validate the new systems and our facilities? And what further risk mitigation activities are needed? Once you have all of these questions answered, you'll be able to go through the fourth gate and start scaling production. Now, once you start scaling, you'll be qualifying either new equipment or qualifying new facilities. Either route you go, you'll be taking that test data and verifying it against the benchmark data that you've gathered during production. You want to make sure that your quality in scaled production meets the same level of quality that you had during production. You'll notice that again, since cost is a lagging indicator, you'll get a bit of a bump in your unit cost. So if we look at the solid green line, this is a lower increase in unit cost because in this instance, we went with adding more machines and more personnel, but not changing the facility. So we already have staff that have learned those lessons throughout production with us. The second option is if we decided to bring a new facility online, and they have a bit more of a steep learning curve to catch up with all that we've been learning throughout production. So you'll have a higher spike in your unit costs represented by the dashed green line, but you'll see again that will start decreasing and they'll both come back down to steady state. So long term, we know that there will be market fluctuations. That's just a fact of life. So maybe between one order and the next, our powder costs more, or perhaps the price of gas has gone up. Either way, we'll have relatively uniform unit cost, but it will have some fluctuations. During the sustainment stage, we'll have our steady state effort to maintain our scaled production. So when scaling production, be aware that it takes longer and more investment to bring less experienced manufacturing operators online. It can be pretty easy to overwhelm a new supplier, so start small and ramp up. I've had the opportunity to be on a number of facility audit teams, and it's always interesting how different some of the facilities can be. I'll go into one facility and I'll be really impressed with the knowledge of the people, the detailed processes that don't have any gaps, and the training regime. I'll feel completely comfortable that if they hire someone new who goes through the training and then has access to the processes, that they'll be able to maintain the current level of quality that the facility has at the current production level. Unfortunately, I've also audited facilities where that's not the case. We'll still have incredibly skilled people, but the processes have some holes. And so it's easy to see that the level of quality that's there today is just because we have some really sharp people in key roles. But what happens if they get sick, or they decide to change companies, or so many new orders are coming in that a lot of new personnel needs to be hired? When you scale in a facility like that, then you have a few more concerns because of the gaps in the processes and or the training regime. So make sure that you really do some detailed reviews of the facility you want to partner with when you're scaling up production, so that you guys can, since you both will be in it together. So when you're scaling production, be aware that you also will need to scale your post-processing capabilities. So don't forget about those. And throughout this whole process, make sure that you keep your customers and stakeholders informed, as this builds trust. And this will allow them to be ready to accept your new quantity of scaled products as soon as it's ready to go. And finally, keep in mind that consistent build layouts drive production efficiencies. So what I mean by this is, if you are sending the same quantity through your orders, same recurring order quantity, then it's going to be really easy for the manufacturer to reuse their build file. They're not going to need to spend the time and labor to redo that and then retweak their processes and travelers. And that lack of touch labor, let's say, will actually be reflected in your unit price. So the more consistency that you can bring to your scaled production, the more efficiency and the lower the unit costs can be. Lessons learned throughout this product lifecycle will help you jumpstart into the next one. So keep in mind that in reality, your next project may not wait for you to finish the first one. So it's really important that you incorporate your lessons learned as you go. So it's important for you to address the expectations. Feel free to use this presentation and share it with your executives and your team, so that they'll be clear exactly what questions you'll be able to answer in each phase of the production lifecycle. Make sure you discuss the project expectations with your executives and your team early and often. Forecast reality into your project planning, and communicate realistic product expectations with stakeholders for a smoother adoption. So while you address the expectations, make sure that you prepare for reality. Now that you have a better understanding of how the process really works, that understanding will be able to be the foundation for your future success. Thank you, and I hope that you have found this presentation helpful. I'd be happy to answer questions.
Jillian, that was a lot of great content. Thank you so much for sharing. Apologies.
Oh. Afraid I lost you, Lindsay. But I see some of the questions, so I'm going to go ahead and answer a few. Hopefully, I'll just go in the order that I see for the votes. The first question that I see is, what are challenges organizations often take for granted when embarking on IAM? One of the things that I've noticed is that sometimes people don't quite understand that there is variation from machine to machine. So if you're in an industry that has, such as aerospace or automotive, and you need to have very detailed qualification and data results, you'll need to take that into account. It's not so easy as just pushing a button and bringing that second machine online. There is some investment and labor that's involved to be able to do that. The second question I see is, how do you get executive buy-in? And do the numbers tell enough of a story, or do you need to sell the AM dream? That's a very good question and a tricky one. There's a line that you actually have to walk. You can't sell the dream so much that they're in the clouds, but you need to get them excited for what additive can do for the bottom line. So since they're project focused, walking that line is going to be much more important than telling them how great of an improvement the performance results alone will be, because that won't get them quite as excited as understanding the impact to the bottom line and what it can do for the business as a whole. So I would spend some extra time understanding your business case in and out, understand your company and potentially each executive's individual pet projects, let's say, or the individual things that they look at that get them excited, and make sure that you're able to answer how additive will impact that particular key aspect of the business. And once you've done that, you'll get your executives excited and help sell the AM dream. And the last question I see are, what are the challenges of getting engineers on board? Also a great question. But again, since engineers are product focused, that's where we'll focus on the increases in product performance, increases in freedom for designability. What can we do today that we only dreamed about yesterday? Things like that, and understanding what realistic capabilities are. Because again, you want to sell the AM dream, but you don't want to sell it too much. Don't give false marketing numbers. Instead, spend a little money on prototyping if you can, to find out what the real numbers are for either your tolerancing or your specific features for your product. So then your engineers can be excited and they will dream big. So give them information and the sky is the limit after that.